Thank you for joining us on episode 60. We're going to do a little language roundup, which is actually kind of inverse of maybe what it should be, because what we're going to talk about is some of the larger languages that you can program in, or you would be forced to program in if you had, if you were working in a little language, a pure language that didn't allow you to do some of the things that most mainstream languages allow you to do without any consequences. And the idea being that in a pure language you would be forced to write some of these things in these larger languages so that that code is separated from the rest of your pure code and you can think about it segregated in that way. So let's jump right in. So if your language didn't have null, you'd have to create something like maybe. You'd have to, because you've got things like arrays, and if you wanted to get the first element in an array, if you didn't have null, you'd have to have something. You'd have to return something. You couldn't return null, so you'd have to be dealing with the maybe language. So you'd have to deal with maybe, where you can have things like just and nothing. So if it's an array of one element or more, then we would get a just of the first one. If it's empty, then we would get a nothing, but we still return. We're now dealing with a program that's in the maybe language that uses the maybe language, and we know that because this program returns a maybe. So what if your language didn't have exceptions? Well, then you'd have to have something like either. So with either, what we're going to say is, without either, you really wouldn't be able to write a divide function if your language didn't have exceptions. And this kind of presupposes that it didn't have null as well. These two are kind of linked together. They're very, very similar. Either is, or maybe is actually kind of a specialized case of either. But when you would use the two is typically quite different. So with either, we can have a divide function, and if y is 0, y being the denominator here, then we can, rather than throwing an exception, we can put that into our type system here and say, well, that's cannot divide by 0. We're not throwing an exception here. We're staying within the type system and always returning an either from here. It's just which instance of the either do we return? Do we return a left or do we return a right? And so the either language allows us to deal with things that can be either a left or a right. Some other languages will do this as a success and failure case. The either is what's called right biased. So typically the things that are good you put on the right, which is kind of a mnemonic there, right, good, and then left would be things that aren't quite what you think they should be, such as this case. And so if we divide 3 by 1, we get 3. If we divide 3 by 0, then, of course, we would get a left and have our value here. So we couldn't throw an exception, but we can put our entire program into this either program. And when we do that, this either language, when we do that now, we're forced to deal with the fact that whatever we call into, that this program might not produce the type of value that we would hope. Because we can't guarantee for every x and y that we can divide those two. So what if your language did not allow effectful computation? I think these two are pretty easy to understand, and then when you get into I/O, most people have not worked in a language very often or at all, where you couldn't just write something to a file, or read something from disk, or generate a random number, or any of those kind of things. So that's what this I/O is about, because in a pure language you wouldn't be able to actually affect the system around you. So I/O in a sense is kind of like, it's almost like a little mini Docker language. So anything that happens within I/O is describing what would happen when it was run. You're not actually performing that. So With I/O, I/O typically receives a function, and in this case we're receiving a function from unit, so basically a function with no arguments. And we're going to log whatever this S was. So if we log I/O hello now, we can see that we're now in the I/O language. And our entire program will have to be within this I/O language. And at the boundary or something else will, at the very, very boundary of our application, will actually run this I/O when it's ready to run that I/O. But what's interesting is now we can do things like we can shove everything into this I/O language that we would, if we were in a pure language, if we had a small language, we would not be able to do this sort of thing. And by wrapping it in this I/O and it forces anyone who's calling into this to realize that what it's doing is something that's potentially unsafe, and you need to have caution. There be dragons here potentially. Console log probably is all right, although there is the goofy old IE bug where console's only initialized if you have the dev tools open or whatever. So there is that. And the last one that we're going to cover today is, what if your language didn't allow network communication? So if your language didn't allow network communication, which if you were a pure language, it wouldn't allow that, you would have to have something like a future or a task or something like that. In this case, we're using future, but you would have to have something like that, because a network call being made is for sure a side effect. It's for sure non-deterministic, because you are deferring to something else as to what value is getting returned. So it could, whoever you're calling to there could change that at any moment. And your program can't, your pure program would not be able to reason about that unless you put everything into the future language, which is what we're doing here. And we're just using this required GOT so that we can, simulate something that would issue a web call. And so what you see here is we get an endpoint, and we wrap our regular code that we would have here, this GOT, which we would have in an impure language, we could call this GOT. But if we're in a pure language, we're gonna have to put that inside of this future language that we have here. And the reason that we have to do that, the reason that GOT would not be allowed in a pure language, is as soon as I call GOT, as soon as I pass an endpoint to GOT, immediately GOT goes off and tries to do stuff. So because it is eager in that sense, or because it immediately performs a side effect, GOT is not pure. But by wrapping it in a future, what we end up doing is we delay that. And some people get caught up on why this is pure and why this is not pure. And the reason is that every time I call HTTP GET with the same string, so let's say every time I call this function with this string, I get the exact same function back. So it's deterministic. I could memoize this, essentially, and it's going to return the same thing every time, and it has no side effects, because what happens is I get the same future back every time. I get a future that's preloaded with the same endpoint every time. That's pure. Every time I call GOT with an endpoint, it makes a web call and starts and basically tips over that first domino. So that's impure. The cool thing here, of course, is that if we're returning a future, every caller that wants to deal with this, when this thing actually gets run, we'll have to call fork, and we'll have to handle both the rejection and the success case. So in that sense, future also kind of does some things. It kind of squinches up this I don't know if squinches is a word. I'm going to say it is. Squinches up I/O, and also either, and then we've seen either kind of deals with maybe a little bit. So in a sense, all of these things could be rewritten, or can be written in the context of future, because it kind of has a lot of those things built in to it. But there you go. So that is, if you were working in a small language, or if you were working in a language like JavaScript and you wanted to be very pure about the code that you were writing, anytime that you needed to do some of these things, rather than persisting null through, you could use maybe. rather than throwing an exception, return an either. Rather than actually logging to the console, wrap that up in an I/O before, map through and do whatever you want to do, might map and chain through on your computations. And then you could have something at the very boundary that would actually run the I/O. If you have to make minute work calls, you could use a future. So that's just a little bit of roundup. So if you've heard things like the maybe monad, the either monad, the I/O monad, or the future monad, this is the stuff that people are talking about. Because all of these things are for sure monads, which means they're also applicatives, which means they're also functors. So there you have it. I hope you enjoyed it. Let me know what you think, and thanks for watching.